Hello everyone, my name is Diptiman Neok. Today I am going to present my talk whose title is A Comparative Study of Some Parton Distribution Function Sets under the supervision of Dr. Akbari Jahan, Department of Physics, Northeastern Regional Institute of Science and Technology, Nirjuli, Arunachal Pradesh. Abstract. Parton distribution functions reflect the underlying structure of proton and thus the dynamics of the interactions of quarks and gluon inside it. PDFs are instrumental in the QCD analysis of high-energy processes. We study some PDF sets in a wide range of momentum fraction x and different q-square ranges also. The numerical values of all PDFs have been taken from LSA PDF library, which is an easy-to-use interface to PDF sets. Various fitting groups produce sets of PDFs of the nucleon, some of which are MSTW, CT10, NNPDF, and HERA PDF. The main features that distinguishes them is that data on which they are based. In our present work, we obtain the plots using FEPL and compare the PDF sets. A comparative analysis of gluons extracted from the different global feeds has also been done. Now, introduction. Parton distribution functions are the essential part of collider physics that allows us to make high-energy theoretical predictions for experimental measurement of hadrons. The dynamics of the interaction of quarks inside the proton through the exchange of gluon results in a distribution of quark momentum within the proton. Such a distribution is expressed in terms of PDFs which reflect the underlying structure of proton. And also, in quantum chromodynamics, PDFs are the most important quantities to study the structure function of proton in deep inelastic scattering. Now, methodology. Study of PDFs open a new way to a better understanding of the partonic quark-gluon structure of the nucleon. In this paper, we present EPIFEL, a new PDF evolution package that allows performing deep clef evolution up to NNLO in QCD. We have been taken various fitting groups produce sets of PDF from LSA PDF library, some of which are MSTW, CT10, and PDF. We obtain the plot using FEPL and compare the PDF sets. Now, these are my results. On the first three columns, the plots are gluon versus X from different PDF sets which are CT10, NNPDF 3.1 and MSTW 2008. And the fourth column represents the comparison of structure function versus X from these three different groups. And the value of Q taken from very low to high ranges. The PDFs falls as X approaches to 1. And these are the standard behavior of the PDF. In the intermediate range, PDFs first fall and then rise and then finally falls as X approaches to 1. This may be due to NLO and NNLO. And also, the PDFs rises with Q at small x, where the C quark dominant, and falls with Q at large x, where the valence quark dominant. Now, the conclusion. Plots of the gluon versus X as well as the proton structure function versus X for a few representative values of Q using FEFL have been studied. We have compared multiple datasets from NNPDF, MSW, and CTEC. In the structure function plot, as a function of X for a given value of Q and flavor, it can be observed that the PDFs falls as X approaches to 1, which are expected behavior of the PDFs. In a few plots for small x and low q, the intermediate x ranges shows the fall of PDFs at first and then rise and then again fall as x approaches to 1. This may be due to the dynamics of NLO and NNLO in this range. Now, these are my reference, and thank you all.